So my name is Marco Russo. Good evening, almost. This session is about Power BI and performance in Power BI. On SQLBI.com, you will find much of the work I and Alberto Ferrari do, and many tools and articles and white papers related to what you will see in this session come and are available from our website. This is the agenda of today. The QR code and a URL are available for you to download the same demo files I will use in this session. So just in case you want to try the same things, you can download the file and try by yourself. The goal is to understand what are the main techniques and tools that we need to use to figure out where is a bottleneck in the performance of a Power BI report. So this is the purpose of the session. We are not able to see and to understand what are the reasons and how to solve each possible performance issue that you can have. The goal is to figure out what is the visual, what is the measure that is responsible, and then, of course, optimization is just an entire course and many chapters of a book. We cannot fill it in an hour, but at least knowing where to start and what to exclude could be very useful. Okay, so this is just to set the right expectations. So let me go straight to the first tool that I want to show you, because Power BI in May 2019 introduced a new feature that is called the Performance Analyzer. This Performance Analyzer is a great help, and actually when I did this presentation more than 2 months ago, I had to spend 10-15 minutes just to explain how to capture the queries generated by a single Power BI report. So what I'm going to do, I have a Power BI report that in a moment I will show you, which is full of visuals. And each visual in Power BI generates at least one query to the Power BI engine. That could be responsible for the performance, but could be also responsible for the duration of the rendering in the page that could take some time. So now that when I will switch to this sales page, you will see a number of visualizations. And one in particular is lower than others in this area, in the lower left corner here. There will be a visualization that is lower than others. So you will see the spinning. This will not take much time. For this reason, I'm explaining in advance. It will take just 4 or 5 seconds. But because I will repeat this cycle several times, you have to imagine that you should multiply by 3, 4, 5, or 10 the timing that you will see during my presentation, because otherwise, if we wait 1 minute every time I repeat the demo, it will be very, very long time. So we will just try to figure out who is responsible for the 4 or 5 seconds of waiting we have, and we will try to reduce it to a minimum, to less than 1 second. Our goal is in less than 1 second, we want to see our report rendered together. Okay, so let's start and see what happens. If I click here, you see that the number of visualizations appear, and it takes a few seconds before this one appears here. So what happened here? Imagine that when you do this in in another report, it could take maybe 10, 20, 30 seconds, too much for many people. So first of all, we waited this time the first time we went here. So if now I click here and I go back, you see that the timing is much sooner. And if I click on a slicer here, if I change the slicer here, you see that these numbers appear quickly, but this one takes 2-3 seconds. So I can see there is something that is lower than something else. And I know that the first time I open my report, it is lower than the other times. So we have to figure out what is going on. First of all, I want to show you one tool before even just showing you the Performance Analyzer in Power BI. I want to show you this tool, which is Task Manager. Maybe that I have to switch back here. Here we go. So let me try again, because Task Manager, it was open there. OK. Task Manager is a tool that you have in Windows and shows you what is running on your PC. Why am I showing you this? Because I want to show you that when you run Power BI desktop, you're running an entire client-server system made by several processes. Each one is consuming CPU and RAM on your PC. When you publish your Power BI desktop file on PowerBI.com, a few of these processes are running on Microsoft Server, on a Microsoft Server on Azure, but you still have to be worried about that because at that point, instead of using the RAM and the CPU of your PC, you are consuming CPUs on a shared server with many other people. Either you work on the Microsoft Power BI Premium or PowerBI.com and Power BI Pro subscription. In both cases, you are consuming resources that are shared with other users in your company or in other companies. So you have to be worried because actually my computer has much more RAM and CPU than a server, and especially a shared server. So it's critical to figure out whether the memory that you are consuming is a problem or not, because sometimes the problem is that you just have a slow report because your computer doesn't have much RAM. So let me explain quickly what we have here. When you run Power BI Desktop, you have a process here, which is with this icon, the Power BI icon, that is like the host process that loads your file and coordinates the activity between all the other processes. The model that contains the tables, the measures, and the data is this one, Microsoft SQL Server Analysis Services. Yes, Microsoft provides you a free copy of analysis services running on your desktop when you get Power BI. And this is actually the same code that runs on SQL Server Analysis Services 2017 or 2019, but it is just adapted to run for a single user on your machine. This service that is running provides the data to the other services, which are mainly these instances of a browser. When you open Power BI, most of the content that you see in the screen is rendered through the same engine that runs a browser that interprets JavaScript and HTML5. And why this is important, when you use a visualization, a visual, or a custom visual, you are consuming memory for the rendering. And each visual, especially when you use custom visuals, each custom visual has a memory cost for the sandbox that is not necessary when you use a native visual. This could be a problem when you have too many custom visuals in a single page. And if the problem is that you have, for example, a chart that has a lot of points, a lot of data points, the rendering time will see, for the rendering time, you will see a large amount of CPU time here. When you see memory and time consumed by these processes, you have to be worried because this will be a problem for the users connected to PowerBI.com because it will be time and memory consumed by the browser of the users. And if you're running a machine like mine with 32 gigabytes, and you see that this processor is using, for example, 6 or 8 gigabytes, you have to be very worried because a few users in your company could use a machine that has a small amount of RAM, for example. Now, in this particular case, when I run my report here, if I try to refresh this by clicking, for example, on North America and just see what happens, you see that, yes, I'm consuming 1 and 1.4 gigabytes in my machine, and you see that these processes are consuming a lot of RAM, but not too much. 200 megabytes that are consumed on the machine of the client of the user could be something that almost any PC should have. So I'm not too much concerned in this particular case. But sometimes this could be the problem. And if you try to optimize everything else and you don't look at these numbers before, you may lose the real reason of something that is going slow. Just it's not interesting for us today, but this mashup evaluation container is the process that runs your Power Query transformation. When you extract data when you refresh the model and you extract data from the data sources, you will see time and memory spent here. Now, we are interested in what happens here at this point because, okay, you see that most of the RAM, and when I refresh my model, also some of the CPU is running here. So at this point, knowing this, we can also interpret the numbers that will be provided by our new tool, which is this performance analyzer. If you go in the view ribbon of Power BI and you click on this performance analyzer, you see a new pane appearing here, and I will use this pane to measure, to capture what happens in my page. So what happens when I click Start Recording? Basically now, whatever I do, it will be recorded and tracked in a list of events here in this list. And this happens, for example, if I click on a slicer. You see that when I click on a slicer, because I requested to refresh the visualizations with new data, you see that each element here has a line here. And when I click on an element here, you see that the element that I selected is highlighted in my report, which makes it very easy to recognize who is responsible for something that happened. Moreover, you see that here I can sort this data by duration. And the duration is provided in milliseconds. So now if I sort in a descending way, you see that I immediately notice that the more expensive visualization that I have in my report is this, the matrix. You remember bottom left corner. And here you can also see that actually the responsibility for this is mainly the DAX query and not the visualization. Visual display is the time you spend for the rendering. So we already recognize, okay, this is a problem of DAX that I can probably try to solve by changing the measure or by changing the data model. But before navigating into this, I want to explain something that could be confusing, which is, for example, the other time that you see in many of these visualizations. If you look at the number and you don't know what is the meaning of these informations, of this information, you may realize, okay, there is something else going on here. Actually, when you have many visualizations, it happens that the rendering engine cannot display all of them at the same time. So you see many spinning around, many wheels spinning that says, okay, there is something running. But actually, several parts of the engine have a limit of the number of operations that they can do in parallel. And so this is time that is required for a visualization, sometimes just to wait some other visualization to complete the work because they depend on it, or because it is just there are just too many operations going on. So basically, when you see other that is a high number, try to ignore it. That's the best way, the best thing that you can do. And last week, with the new release of June, Microsoft added this feature that was not available before, which is a sort by action order or DAX query or visual display or total time. Until May, the only visualization, the only sort order was by total time, which was quite confusing because sometimes you had a visualization that was not expensive at all, but was just the last one to be rendered, and most of the time was other. So what makes sense to do is, if you know that you have a problem in the visualization, or you just want to take a look at what is the more expensive visualization to render, you can sort by visual display. And you see that by visual display, oh, this one is the one that takes longer to render, just a sentence, blue text, which is probably not really true, but remember that you also have to consider that any timing below 100 milliseconds, you cannot really trust too much because the precision, the accuracy of this timing is usually 10, 20 milliseconds. So I will start to worry about something that requires 200, 300 milliseconds or more. And usually, once we can exclude that we have a problem in the visual display, that could be the reason for usually a chart with many points could be the problem, or a map. A map with a lot of data points could be a problem in visual display. Usually what we do, we sort by DAX query, because the DAX query is what we can control, what we can analyze and measure better. Okay? Now that I have this now that I know that this DAX query could be slow, I can copy the query. and copy the query basically copies the DAX statement into the clipboard, and I can show you the content of the clipboard in an editor. Okay, so I can see this is the DAX code generated by the visual. Now, if you know DAX, you already know what is the role of this. But basically, every single visualization that you see in a page generates at least one DAX query. And as you see, I created many of them. So this page is not optimal because it has too many visuals. And this will generate too many queries. But now that I know that this particular visualization generates a single query that is expensive. And this is the code of this query. Now, what can I do with this code? Well, this query by itself, this query is the request that the user interface of Power BI sends to analysis services in order to obtain the information that will be used to render the table that you see here. So what we can try to do, we can try to execute the same query in another environment, trying to figure out which part of the query is lower. So this is exactly what I'm going to do now. And before I move forward, I just want to recap that the performance analyzer is a tool that enables us to capture the timing information of each part of the visualization in a report page. And also, we can copy a single DAX query generated by a single visualization. And we can use this information with some other tool. And the tool that I will show you now is DaxStudio. DaxStudio is an open source tool that you can download for free and install on your machine from a web page that I show you in a moment, which is DaxStudio.org. You will find in this visualization here. And DaxStudio.org, you can see here, you can download the tool, you can install the tool, and there is some documentation and some examples, some video that explain how to use it. For the purpose of the demo today, I just installed DaxStudio here. I run DaxStudio, and DaxStudio has been designed to be connected to analysis services. But as you see, you can click this option, Power BI or SSDT model, and you can connect it to an open instance of of Power BI. And DaxStudio will connect it to the hidden instance of analysis services that is running behind Power BI. So the sequence is I open Power BI, and then I use DaxStudio to connect to that instance of Power BI. In case you have multiple windows with Power BI open, you will see a list here with multiple names. Now, once I connect here, I can see here the tables, the columns, and also the measures that I have in my model. And I have a number of tools here. And let's start from this. I can run a query. What is a query? For example, I can write a query in DAX, like evaluate, and for example, the table product. And by doing this, if I click on run, you can see here in the result the content of this table product. Now, product is just the name of a table, but actually evaluate can accept any function in DAX, any DAX expression returning a table. And if you remember, I copied in the clipboard this. This is a DAX query. So if I copy and paste this query here, and I execute the query again, clicking run, I can see exactly what is the result, what is the content that analysis services provided to Power BI desktop, in this case, to render the visualization. And the visualization just use this data to generate the information. Now, take a look at this result. We have 3 columns here, product name, customers, but we have a is grand total row total, which is true only for one row. And the visualization in Power BI actually uses this information to create a different type of visualization where the row that was blank and was the first in my result is actually the total that you see at the bottom. And you can scroll this list, but actually this is always at the bottom. So you see that the way the data is presented to the user is not necessarily the same way that the same data that is returned to the visualization. So the visualization does some work, but usually if the query is low, we can already analyze this here. Now, DaxStudio is a tool that does many things, but what we are interested to do is using this part of DaxStudio where we can analyze a specific query, capturing the query plan and other information about the execution on the server of the query. Because remember, even though we are using Power BI Desktop, we are actually using analysis services. Once I click these two buttons, you see here at the bottom, two areas, query plan and server timings, which now are blank. But what I will do now, I will execute my query again. However, before doing this, I want to make sure that every time I execute the query, first I clear the analysis services cache. Because the cache in analysis services could solve the query in 0 milliseconds, but I want to see what happens in the worst case scenario. Especially, that is not necessarily the one we have when you open the Power BI file, but also when you click on a combination that is new for Power BI, for example. So if I run this query again, clearing the cache, what happens is that you see here in the server timings area a set of numbers and some information here that I will describe in a moment. But usually you might expect, oh, query plan. Let's take a look at the query plan. You expect a nice diagram with many arrows and colors, and this is what we have. Because it's just a list of operations that describe the query plan. Because this is what we get from the profiler event that describe what is going on. Now, we could try to understand what is written here, but usually, even when you have a lot of experience in DAX, it is just more productive to start here and to analyze what is going on. So I know that my query should just create a small table with a list of values. But here I see that I'm spending 1.5 seconds, and this timing is spent between formula engine and storage engine. What are these information? Well, these numbers that I'm looking at could be too much or a good number. How can I know that? First of all, I have to combine my knowledge of the query that is running with my knowledge of the data model. And sometimes it could be useful to have some metric to compare the numbers that we see with the objective analysis of what is inside my model. So this is just a few slides that I will provide you are just a recap of what we have seen in DaxStudio and the features of DaxStudio, some link to some article describing how to capture the queries in DaxStudio, something that I'm describing you in the presentation is also written in some article, and you will find several references in the slides. One tool that could be useful, however, is Vertipack Analyzer. So maybe if I had a model with 10 billion rows, the numbers I got would be good. But how can I know whether my model is large or not? Well, if you have Power BI Desktop, any model you can have in a Power BI Desktop on your PC, a query should run in a few hundred milliseconds, maybe when you have a lot of data. Unless you have some complexity in your calculation, which I don't think we have, but we will see in a moment what is the formula. So why Vertipack Analyzer could be useful? Because Vertipack Analyzer is a tool that enables you, just let me open, I forgot to open this. Vertipack Analyzer is a tool that you can download for free. It's just an Excel file in reality, which allows you to see what is inside your model. So now when I open a Vertipack Analyzer, I just have an Excel file which has a Power Pivot model that, however, is filled with data of a sample database that is different than yours. So first of all, I want to populate this list with the data that I have in my model. So I want to refresh this model with my model. And the way you obtain this is by going in the Power Pivot model that you have in Vertipack Analyzer, specifying as a connection the same connection to the analysis services engine that is running behind Power BI. Now, this connection, how can we know this connection? So we want to write something here, we want to write something in this dialog box so that instead of having this string or another string, we have the right one. Well, if you remember, I showed you that I connected with DaxStudio to analysis services. to the analysis services running behind Power BI. And DaxStudio provides me the exact information of what is this connection point that enables me to connect to the same model that is running under Power BI Desktop from Excel, for example. So I just have to remember localhost is always the same, but the number changes every time you open Power BI with a new file. So I have to write here 51336, which is the number I got from DaxStudio. And then you have to remember to select here the whatever name appears, but this name is required, otherwise the connection will not work. So now I save this, I close, and I go back to Excel, and I go to this Vertipack Analyzer ribbon, and I click refresh. This is just because the refresh activated this way is slightly faster than doing the same refresh operation from within Power Pivot. Here we go. Now we have the list of the tables of our data model, customer, date, product, sales, and segments. And for each table, you see the sides of the table. But for each table, you can also see the sides of each column and the cost of each column. And you see that the size is different for every column. And these sides can have a relationship with the time required to scan the table, to scan the column, and to execute the query. Now, it's not really interesting now to move forward to analyze in more detail these numbers, because I can see that my entire model has a data size of 200 kilobytes, which is a very small number. We should expect a query to run in 1 millisecond, basically. So I can exclude that the size of the model is now a problem. So I just have to understand what is going on in my particular query. Because if you remember, the time was more than 1 second for my query. So as I said, the query plan is not really useful because there are a lot of details, but actually not something that we can understand immediately. But we have seen strange numbers when I went to the storage engine analysis, so to the server timings analysis. So what is going on? In order to explain you the two numbers, you have to be aware that there are two engines running for analysis services and the tabular model, which are the formula engine and the storage engine. The formula engine is what really understands DAX, whereas the storage engine is, when you load the data in memory, a very, very quick in-memory columnar storage engine, which is very fast, but also can solve only very, very simple queries. And when you use direct query, the storage engine is your SQL Server or your Oracle database. Now, we're using data in memory, so actually we have a storage engine. And basically what happens is that whenever the DAX query is executed, the DAX query plan generates one or more requests to the storage engine that provide the data to the formula engine that executes some additional processing to provide you the final result. These are the events that the SQL Server Profiler would capture for you, but DaxStudio is capturing this data and is computing this data, providing the same information in a much simpler way, because otherwise we should do some calculation, we should exclude some event, and so on. We don't have to do this. We can just use DaxStudio, the numbers of DaxStudio, to analyze what happens between the formula engine and the storage engine. Now, when the formula engine requests something to the storage engine provides a result that we call a data cache. And the data cache is just the result that is sent to the formula engine, and the formula engine consumes to produce a result. So each query sent from the formula engine to the storage engine produces a small table in memory, and the formula engine consumes these results to provide the final result. Now remember, we sent one query, we obtained one table as a result. So let's try to see the numbers with this in mind now. I spent 421 milliseconds in the formula engine and 900 in the storage engine. So I would say, OK, first of all, we have a storage engine issue. But then I look at the number of queries that have been sent to the storage engine, and I see a large number, 429. So I say, wait a minute. Usually, I would expect 1, 2, 3 queries to the storage engine. Why a single simple request is generating 429 queries? Because now if I divide the storage engine time by the number of storage engine queries, each single query was running in 2 milliseconds, which is what I expect, 1, 2 milliseconds. So the problem is that there are too many storage engine queries in this case. And then, of course, the formula engine has to spend time because it has to generate these queries. So let's take a look at these queries here. The list here is the list of the queries sent to the storage engine. And as you see, the language that is used to describe these queries is similar to a SQL. It's called XM SQL. These joins correspond to relationships that you have in the model. And you see that this query generates a list of estimated number of 17,000 rows and 100 kilobytes in memory. This is an estimation. It's not necessarily the right number. The right number is available in the consumption in the query plan, where we can see that actually the result of this, the query produced 427 records, so a much smaller number than the 17,000 estimated. But remember 427, because if you see, there are 429 queries. So it seems that many queries have been sent with a very similar pattern, and this is actually what happens. Look at this query. There is a distinct count from where condition. If I click on the next, you see that it is repeating the same query several times, just changing the arguments of the where condition. At this point, I need to understand what is going on. And in order to understand what is going on, I show you that this query is using just a measure, customers. And when you identify the visualization, you can actually figure out what is the measure by just looking at the property of the visualization. So if I go back to my report and I click on this visual, you see that here, in my visualization pane, hopefully, what happened? There's a spinning, nice. Very good. OK, it works now. So if I click on this, I see that my measure customers is the only measure displayed here. So it's easy, in this case, to figure out what is the measure that is responsible. When you have a more complex visualization, you might have many more measures involved. And so what you can do is you can move the definition of these measures here within the query, because this way you can play with what happens if I change this definition of the measure without actually affecting the model. You see that I can also format the query here. And why I'm doing this? Because when you have a real-world problem, you might have many measures, and you can start applying changes, but you don't want to really modify the model, because at a certain point you may forget what was the initial working version of the measure. And now, of course, from here and after, you have to know DAX, you have to know what could be the reason why this particular query plan is not efficient. And I can tell you that here, I'm doing a very, very big mistake, which is in a calculate statement, I'm filtering by using a table and not by filtering a column. So in order to retrieve the same result with a better semantic index, I just want to filter the column, keep in the filter because this is the semantically equivalent condition that than the filter that I wrote before. And now by specifying a filter column instead of a table column, I remove the constraint that forced the query plan to generate a very inefficient query plan. So if I run this query again here in this test environment in DaxStudio, what happens is that my query ran in 12 milliseconds. And actually, the storage engine is just 0 to 6 milliseconds. Actually, as I said, any number below 10, 20 milliseconds is just it could be noise. But what is the reason for that? Now we have only 2 storage engine queries. And the storage engine query that does the distinct count does the distinct count with a single request for the grand total, and another single request for the distinct count for every product name. So we have 1 storage engine query for 1 granularity by product and 1 for the grand total. And this, of course, solves the problem in this case, because the storage engine should be very, very fast for something that you have in PowerBIUG desktop. So the problem is that we were generating too many storage engine queries. Okay, so this was the problem in this particular case. So XM SQL is the language that is used to describe these requests made to the storage engine. And the XMSQL usually is not able to do complex stuff. Now I was doing a distinct count, but when you create queries that use complex function in DAX, not aggregation, but just functions to transform data or to do complex mathematical calculation, you will see that XMSQL is not able to solve them, and so it will call back the formula engine, or it will generate, it will materialize in memory some data that will be consumed by the formula engine to solve the problem. So this could be a way to understand what is going on analyzing XMSQL query, because whatever is not executed in a storage engine in this request will be certainly executed by the formula engine without having to read the thousands of rows in the query plan to understand just this information. One of the problems is that the data caches are materialized uncompressed. So you have compressed data in memory, but when the data is transferred from the storage engine to the formula engine, it is uncompressed. And this could require memory on your PC or on PowerBI on the server side. And this could be a problem for the scalability. A report that is not too slow on my machine, but is consuming 500 megabytes on my machine, will be a problem when 20, 30 users will try to execute the report at the same time on the server. Because also in Microsoft Server, there is not an infinite amount of memory, and this could be a problem. As I mentioned, I wanted to clear the cache of analysis services before running a query, just to make sure that I was getting the timing in the worst possible case, which is I'm opening a page for the first time. And this is the internal message that is generated by DaxStudio to clear the cache. We don't have a clear cache technique in Performance Analyzer. Here, when you refresh the visual repeats the request to analysis services, but analysis services could reply with some data that is already in cache. So this is a limitation that there should be a clear cache, a clear analysis services cache button here. Because we don't have it now, you can just go here and clear the cache. Once you are connected with DaxStudio, you can clear the cache by pushing this button, and you clear the cache in analysis services also for following requests made by PowerBI. So I try just to recap, and then I'm open to your questions. The idea is that, first of all, we have to locate the visualization that is responsible for the longest duration. And if this is a DAX query, we can isolate this DAX query and create a repro query that we can run several times in DaxStudio, changing the definition of the measure, finding the bottleneck, trying to improve the performance if we can. Of course, test the query maybe more than once, especially if your machine is running many other things, or if you're testing this over analysis services, because there could be different execution times every time, but usually 2-3 executions that converge to the same number are enough to define, okay, this is what is going on, and you can have a good measure to restrict the problem and try to solve. If you want to know more about, okay, but how can I optimize DAX, there are a few chapters in this book dedicated, the book that you see in the first link has a few chapters dedicated to optimization. We also have 2 white papers that you can download from free. They are not new, but actually nothing changed here. Especially the principles are the same. And these 2 white papers can help you understanding what is going on, especially for the query plan pane. We have seen DaxStudio, we have seen Vertipack Analyzer, 2 useful tools that you can download from these links. I'm open to your questions. Thank you. Raise your hand.
All right. Questions?
Yep.
When you're using DaxStudio to modify that local version of the measure, is there a way to, once you get it working, to save that back to the data model, or do you have to do that in PowerBI?
Good question. Basically, there is no way today to push back this measure to DaxStudio, so you just have to copy and go back to PowerBI Desktop. I can go to my definition of the customer's measure here, and I can paste the code here. This is what I can do today. And of course, if you change many measures, this could be a pain. But actually, it's also a way to make sure that you only modify the model according. I mean, you are responsible of what you do, and not a tool that could do could have some bug. You never know. Question there?
Thanks so much. So when you got to the point where you had broken down everything and we had identified the measure that was the problem and you brought it into, I think it was DaxStudio, you pointed at it and you were like, oh yeah, okay, we have a filter here on a whole table and we know that that's bad. I didn't know that that was bad. I do that all the time. Is there a list of bad things that we can refer to somewhere so that when we get to here?
You didn't read the book.
Sweet, I'll check it out.
But then, now I show you. There is a, okay, I show you one thing. I think here, if I go here, oops, no, here. I want to search for table filter calculate. There's a problem if you write that kind of filter in too many things. There is an article where we describe this, I remember, and not this one. It's a more recent article. Maybe let's try Google. No. Table
Even the
filter,
DAX gods use
DAX
Google.
Calculate the SQLBI. I think this will be smarter. Here we go. I know. So I think that this article explains that you can use this filter, but actually a recommendation about this, where is this article is 2016. No, this article already explained that. Maybe okay, it's not. I don't. Maybe there is another one update here introducing some. No, these are other things. Okay, but yeah, basically, if you try to DAX, in DAX, you should use columns. Is a column-based is a column-based engine. Okay, data stored by column. When you use a table, basically you are telling to the engine, okay, get all these columns together in a table and then do something, which is more expensive than actually saying, I want to filter this column and this column only, which is very different from what you do in a relational database. But the relational database like SQL Server has data stored by row, not by column. So when you filter a table, you always do a more expensive operation. Then if you're lucky, what you're doing is not as dangerous as what I did, because the engine tried to optimize the execution plan, saying, yes, you asked to filter a table, but in reality, you wanted to filter a column. But using the distinct count is one of the simplest cases where this assumption doesn't work well and cannot be made by the engine. But actually, if you have a more complex expression or a more complex data model, if you have a one-star schema, one fact table, many dimensions, that's fine. You can do almost any mistake, and you will not notice. But when you have more fact tables or snowflake schemas, I don't know if you know this convention, but a snowflake schema with different tables, a different granularity, and you have an expression, a complex expression using many of this, oh, come on, that cannot be optimized. If you use the table, you're saying that you want to include the expanded table in the filter context is a total, especially if it is the fact table, you will see very, very big problems. Because as soon as the storage engine cannot solve the request that you made, the materialization provided to the storage to the formula engine must include at least one key for each table involved in the star schema or snowflake schema. And this materialization happens uncompressed in memory. And so you don't want this to happen. If this happens, you will see that the memory increases when you execute the query. And this could be one problem that you can have. So try to avoid table filters. But actually, table filters, the problem that I've shown you, is the second more common performance issue in DAX that you have. The first one is using the context transition in too many times, but that's another problem.
Can I just make a comment also? They have a great optimization video course.
Yes.
Is that
okay.
still up? And
Yeah,
also on their site, they have a couple of videos, optimization videos from that are really quite thorough from summits and things like that. And that's the best place to start for your bad list. They do highlight some really bad things to do.
Rachel would know.
Yeah.
That is for sure. Question?
There are many others. Yeah. If you go in video here, you will find them. Yes. Yeah.
Okay,
I forgot.
So it's related to the flow. Like when you pass a DAX expression, does it go and ask the request is sent to storage engine or the formula engine? If I have a simple expression like sum of, or count of column, does it go through? How does that?
Anything you request always is sent to the formula engine first. Then the formula engine has two options. First, it asks for the result of the aggregation to the storage engine. Second, it asks to the storage engine a copy of the data and then perform the aggregation within the formula engine. Hopefully, it will request the aggregation to the storage engine. But you might create an expression in DAX that requires, that makes more convenient from a query plan standpoint to make a single request to the storage engine performing the aggregation in the formula engine rather than requesting multiple aggregations to the storage engine for different granularities.
So does that mean it'll make two calls for a simple expression?
So, sorry?
Will it make two calls for a simple expression, a formula engine to storage engine?
This could be the problem, but it's a little bit complex because if you think to a formula, you can figure out, okay, this formula has this cost, but the formula has to be considered because you write a measure, but then your measure will be executed in a DAX query that will do something else. So the problem is that the cost is the overall cost of the query, not the cost. You don't have a cost for the measure. You have a cost for the measure executed in a particular report. Okay? So maybe that your measure works well in one context, but doesn't work well in another, for example. So for this reason, I'm unable to answer in a direct way yes or no, because there is no yes or no. It depends. It depends. For this reason, we always analyze a measure using a query that reproduces the problem. And the query captured by a slow Power BI report is good because that query has all the filters and all the shapes that actually generate the performance issue. The same query, the same measure that I wrote, executed in a card visualization is not an issue. Because for a card, there is one query. And if you have 4 cards, there are 4 queries, period. And there is no way to optimize it. You have 4 queries. And 4 queries, each query does a different storage engine query, period. You cannot have an optimization there. So.
Okay. More questions? It's all good. I need it.
This is a question about report tabs. So if you have, like, let's say 10 reports, is it better to have one report with 10 tabs or 2 reports with 5 tabs each from a refresh perspective? I'm not sure if I'm asking that question right.
Just a question. By tab, you mean this is a tab, right?
Yes.
Okay.
Yes.
Okay. I have a good news. You pay the price only for the visualizations for the tab that you display, period. So if I have 100 tabs that I never show, I will never pay the price for them. For this reason, when I opened this file, I had an empty page. It was not just for the demo. It was because if I have an empty page, I can open Power BI, I can open DaxStudio, I can connect DaxStudio to Power BI, and nothing happens so far. Because I still have to go to sales. I can start in DaxStudio, I can start DaxStudio listening to every query, Because before the performance analyzer, we had to use DaxStudio also to capture the queries. The button that you see here, all queries, is actually listen all the queries sent to analysis services. Now we probably don't need it anymore, or we don't need it often now, especially for PowerBIUG Desktop, because we know that this is the slowest query. But before, we had to do this, and it was necessary. But for example, you can do that because you want to clear the cache of analysis services before clearing the cache. So there could be a reason why you want to do that. But actually, to answer your question, no, you don't have to worry about how many reports. Besides the size of the PBIX file, which becomes larger because you have many pages there, but it's not a big issue.
Okay. One more question? Yes.
If you're using direct query, is there any way to determine if the direct query is causing the slowness as opposed to just the DAX measure?
It's easy. Don't use direct query.
I know you hate that answer.
No, OK, I can explain you better. There are different problems. But actually, OK, my suggestion is white paper direct query. We go straight to Google, so you don't risk to not find this. This one, even though it is for Analysis Services 2016, it is the same engine. So you can read this white paper and apply everything is written here to PowerBIUG Desktop. So this white paper explains clearly what could go wrong in direct query. I mean, direct query is lower than the in-memory engine. But it could be much slower than necessary if you don't write a proper DAX query. So we cannot say that DAX is slow. The problem is that the DAX could be not efficiently written for direct query. Okay. And one of the things that can happen is that, okay, if you run the direct, okay, there are these different things that can happen. The query generated by the SQL query generated by the engine could be intrinsically slow, creating joins that are not necessary. So this is one problem. And once again, the table filter that we have seen could be amplified in direct query, for example. This is one thing. Second, if you have too many queries, like in my case, that's another problem because you have a bigger latency going back and forth, so you want to reduce the number of queries. At the same time, also the volume of the data cache provided to DAX could be a problem because that has to be transferred between two different servers, maybe. So you have the network, you have the memory, you have a lot of things. And you know what? One of the issues that you have in direct query, if you use time intelligence, you have one problem. 90% of your reports are by month. Every query in direct query that uses time intelligence materializes data by day. So you are multiplied by 30, one order of magnitude and more, the volume of the data this is transferred from SQL to PowerBIUG. You say, OK, but we have fast network. Think twice. If you are creating a chart with a lot of points, every point which is a month, and you have many products because you have many lines and you have 5 years, do the math. Because you are, maybe those 2 or 3 seconds that you wait are mainly because you have to transfer data, and then once the data is in memory, you still have to interpret the data. Because the data is returned, but is not the internal binary format. You still have to parse it. So actually, a good idea could be that of changing the granularity of the query to the month. But this means that you have to get rid of the time intelligence function, and you have to write the filter by yourself.
We have one
but
more
in the white paper is written.
Any more burning questions? One more, if somebody has one. If not, we can move into raffle and kind of wrapping up. Cool? All right, well, Marco, you want to stay up there?
Thank you.
We got a raffle going. Thanks to Scott from Lexicon, who brought us our Echo Plus, and then all of our amazing sponsors that got us the Yeti cooler. If you want to come up here, Scott. All right, so you have to be here to win, okay? And then you can also win a vacation with Marco. That's one we haven't told. He has no idea. Yeah. They're going to be really excited about that one.
I
Yeah,
get one randomly, right?
Yes.
I'm looking at the... Okay.
No Dax queries. All right. Do we have a Gina Ashrafi? Nelson? Sina. Sina. There we go. All right. You win the Amazon. Yeah. Congrats. All right. Now I know everybody wants the Yeti because we're in Portland and we all love to hike. Don't tell Chris it's not Columbia. It's a trail map somewhere. All right. Oh, man. Where's Iman? Where is Iman? What?
I want something, so I ran to somebody else.
You sure? Dude, look at this thing. It's like a freezer purse bag. Like.
Last time I bought, I got the paramedic sports training for a whole year, so I think it's...
Iman, you're such a sweet guy. You're sure?
Yes, I'm positive.
Oh my God. Okay. Let's give it up for Iman. One more. Yeah.
One more.
That's
go.
awesome.
We go.
All right. What? What?
Paul dot
DAVC.
at
Paul. Oh, it's a Paul. Paul Best. Who's Paul? Is that you? Sorry, Paul. Hey, thank you. It's all good. Hey, that's why we work with data, right? All right. Marco, thank you so much for coming. Everybody, thanks so much for making it again. Seriously.
Thank you.
Thanks to all of our speakers, Chris, Paul, Brian, our sponsors, Metric Insights, Warescape, Lexicon Solutions, really everybody, and the whole community. Thank you guys for making it. Hopefully you can hang out for a little bit afterwards. Hopefully see you at the user group next week. And that's a wrap.